Hello friends, I am your friend Pathak and today we discuss different activities and experiments of Class 9 Science Chapter 1 Methods in our surrounding. So let's start. So guys, our first activity is take a 100 milliliter beaker. Fill half of the beaker with water and mark the level of water. Dissolve some salt or sugar with the help of a glass rod. Observe any change in water level. So guys, we can see that there is no change in water level. This tells us that matter is made up of tiny particles. Okay guys, so move to our activity 1.2. Take 2 or 3 crystals of potassium permanganate and dissolve them in 100 milliliter of water. Take out approximately 100 ml of this solution and put it into 90 ml of clear water. Take out 10 ml of this solution and put it into another 90 ml of clear water. Keep diluting the solution like this 5 to 8 times. Is the water still colored? This experiment shows that just a few crystals of potassium permanganate can color a large volume of water, about 1000 liters. So, we conclude that there must be millions of tiny particles in just one crystal of potassium permanganate, which keep on dividing themselves into smaller and smaller particles. Activity 1.3. Put a until incense stick in a corner of your glass. How close do you have to go near it so as to get its smell? Now light the incense stick. What happens? Do you get the smell sitting at a distance? Record your observation. Take 2 glass or beaker filled with water. Put a drop of blue or red ink slowly and carefully along the side of the first beaker and honey in the same way in the second beaker. Leave them undisturbed in your house or in a corner of the glass. Record your observation. Activity 1.5. Drop a crystal of copper sulfate or potassium permanganate into a glass of hot water and another containing cold water. Do not stir the solution. Allow the crystal to settle at the bottom. What do you observe just above the solid crystal in the glass? Okay guys, what does this suggest about the particles of solid and liquid? Does the rate of mixing change with temperature? Why and how? So guys, our answer is from the above three activities 1.3, 1.4 and 1.5, we can conclude that particles of matter are continuously moving. That is, they possess what we call the kinetic energy. Okay guys, as the temperature rises, particles move faster. So we can say that with increase in temperature, the kinetic energy of the particles also increase. So guys, now move to our next activity. In the above three activities, we observe that particles of matter intermix on their own with each other. They do not they do so by getting into the space between the particles. The intermixing of particles of two different types of matter on their own is called diffusion. We also observed that on heating, diffusion becomes fast. So guys, move to our next activity, that is activity 1.6. Take an iron nail, a piece of chalk and a rubber band. By trying them by harming, cutting or scratching. In which of the above three substances do you think the particles are held together with greater force? Activity 1.7. Take some water in a container. Try cutting the surface of water with your fingers. Were you able to cut the surface of water? What could be the reason behind the surface of water remain together? Okay, guys. So, guys, the reason is the above two activities 1.6 and 1.7 suggest that particles of matter have force acting between them. This force keeps the particles together. The strength of this force of attraction varies from one kind of matter to another. Okay, guys. So, guys, move to our next activity. That is activity number 1.8. Collect the following articles: a pen, a book, a needle, a piece of wooden stick. Sketch the shape of above articles in your notebook by moving a pencil around them. Do all these have a definite shape, distinct boundaries, and a fixed volume? What happens if they are harmed, pulled, or dropped? Are these capable of diffusing into each other? All the above are examples of solid. We can say that all these have a definite shape, distinct boundaries, and fixed volume. That is, have negligible compressibility. Solids have a tendency to maintain their shape. When subjected to outside force, solids may break under force, but it is difficult to change their shape. So, they are rigid. Okay, guys? So, move to our next activity, that is activity number 9. Collect the following: first, water, cooking oil, milk, juice, a cold drink, containers of different shape. Put a 50 ml mark on these containers using a measuring cylinder from the laboratory. What will happen if these liquids are split on the floor? Measure 50 ml of any one liquid and transfer it into different container one by one. Does the volume remain the same? Does the shape of the liquid remain the same? When you pour the liquid from one container into another, does it flow easily? So, guys, we observed that liquids have no fixed shape but have a fixed volume. They take up the shape of the container in which they are kept. Liquids flow and change shape, so they are not rigid but can be called fluid. Okay, guys. So, guys, move to our next activity, activity 1.10. Take 300 ml syringe and close their nozzles by rubber cork. Remove the pistons from all the syringes. Leave one syringe untouched. Fill water in the second and pieces of chalk in the third. Insert the pistol back in the syringes. You may apply some Vaseline on the pistol before inserting them into the syringes for their smooth movement. Now try to compress the content by pushing the pistol in each syringe. We have observed that gases are highly compressible as compared to solids and liquids. Activity 1.11. Take about 150 gram of ice in a beaker and suspend the laboratory thermometer so that its bulb is on contact with the ice. Start heating the beaker on a low flame. Note the temperature when the ice starts melting. Now put a glass rod in the beaker and heat while stirring till the water starts boiling. Keep a careful eye on the thermometer reading till most of the water has vaporized. Record the observation for the conversion of water in the liquid state to the gaseous state. On increasing the temperature of solid, the kinetic energy of the particle increases. Due to the increase in kinetic energy, the particles start vibrating with greater speed. Okay guys, the energy supplied to heat overcome the force of attraction between the particles. Okay guys, so the particles leave their fixed position and start moving freely. A stage is reached when the solid melts and it converts to liquid. Okay guys, and if we heat a liquid continuously, it converts to gas. We must have observed during the experiment of melting that the temperature of the system do not change after the melting point is reached till all the ice melts. This happens even though we continue to heat the beaker. It that is, we continue to supply heat. The heat gets used to change the state of overcoming the force of attraction between the particles. As this heat energy is absorbed by ice without showing any rise in temperature, it is considered that it gets hidden into the content of the beaker and is known as latent heat. Okay guys, so this is a latent heat. So move to our last activity, that is activity 1.12. Take some camphor, crush it and put it in a china dish. Put an inverted funnel over the china dish. Put a cotton plug on the stem of the funnel. Now heat slowly and observe. What do you infer from the above activity? A change of state directly from solid to gas without change into liquid state is called sublimation. And the direct change of gas to solid without change into liquid is called deposition. Okay guys, so this is our class 9th science chapter 1 matters in our surrounding activities and experiments. Okay guys, so we will meet in our next video. Bye, see you, thank you.